Hi everyone, welcome back to the Saga Tech Gate. Today in this video, let us understand one of the fundamental and most important concept in Verilog, the module. Whether you are a student or a design engineer, understanding the module is a key to the digital design. So module is a basic building block in Verilog. Okay, in Verilog, the module is a basic unit of design. So it describes piece of hardware. Anything from a simple AND gate to full-fledged processor can be modeled using a module. So think of it like this. In software, we have functions and classes. In hardware, we'll describe the blocks of logic using a module. Okay, it defines inputs and outputs and also the behavior of the circuits. Now just see simple syntax of a module. So now here module name, here list of ports. Okay, the ports of that given digital hardware, and we declare those ports as an input and output here. And local net declaration will use some intermediate signals or variable to connect different entities in your module. So and also parallel statement like a continuous assignment statement and procedural blocks like always to describe the our circuit behavior. So we can instantiate other modules also here. Right, now see, this is a simple syntax of a module definition. So module and end module name, port list, and by using this parallel statement we describe the internal structure of a or circuits. Now see, I'll to understand this, I'll take a simple example of adder in a beginner perspective. So take this of adder. So everything in a Verilog as a model. So if you want to describe any hardware, then it is as a model. Now I want to describe this hardware behavior of adder using a Verilog. Now it has a two inputs, A comma B, and the two outputs, sum and carry. If you see the internal structure of this off adder, it contains the two gates. One is XOR gate, another is AND gates. Now I'll explain how to write a Verilog code for this off adder. We can write a Verilog code. We can describe the hardware using Verilog in many ways. So we have different abstraction levels in Verilog, like gate level, data flow modeling, a structural, behavioral, switch level, circuit level. We can use either mix of and above also, right? All these also. So now here I'll take a simple primitives to describe this half adder using Verilog, right? Now see, is a module name. Module name, what is the module name here? Module name is half adder. Anything you can give here. So half adder and your ports, inputs A comma B, like A, B and inputs, sum and carry as outputs. These are the list of ports in your module. Now these are the A, B and sum and carry as the ports. Now you declare this A, B as the input and you declare this sum carry as the output. So now you are declaring those ports as the input as well as the output. So now I'll use a simple primitives. We can call these basic gates in Verilog as the primitives. Here I'll use a simple gates here XOR. This is the instant name. Instant name is not mandatory in case of primitive instantiation. So XOR. So now is how we derive the sum functionality by using the XOR only. So XOR G1 instant name and sum. The first signal is the output. So remaining all are the inputs. So that gate has only one output. Okay, remaining all are inputs. So sum as the output here. So in this gate, sum as the output and A or B are inputs. A and B are inputs. So same way, here's the AND gate. So now instant name Z2. Just I'll instantiate. I'll use this primitive gate AND. So instant name is Z2 and the output is carry and it has the two inputs A comma B and end model. This is a simple description of Verilog for a given off adder in terms of primitives, right? So I hope you understand how to write a Verilog code of a simple off adder. So to explain the concept of model, I'll take this example. Right now, see, the Verilog HDL supports hierarchical structure. For hardware description, we'll use a hierarchical structure. I'll explain. I'll take one example. I'll explain how we are implement this hierarchical structure, right? And also, a model can be instantiated within another model. So a model can be instantiated within another model, communicated through input and output and bidirectional ports. So we can define a model. We can instantiate this model in another model also. Right. And also models cannot contain definition of other models. We cannot define one model in another model. Just we will instantiate this model in another model. Right. Now see, what is mean model instantiation? How we will do this? How many ways we can do? I'll explain in this video. So let us consider a simple op adder. having a two inputs a comma b and the two outputs sum and carry. Now this is the corresponding Verilog code. So module name, inputs a b and output sum and carry. I declare those, okay, a b as input and sum carry as output. Then I use this data flow modeling. In the previous example, I'll use primitive. Just I'll use a continuous assignment statement like a data flow modeling. We'll discuss these different abstraction level in coming videos. Okay, right. Assign sum is equal to a XOR b, assign carry is equal to a and b, and model. This is a simple description of a of adder in Verilog in data flow modeling style. Now see, how do I build a full adder? Okay, one bit full adder using off adder. So I'll explain how we are instantiate this off adder in the full adder. Now if you look into this circuit, okay, this model, it contains the two off adders, off adder 1 and off adders 2, and also one OR gate. So now I'll instantiate all these three components in a single full adder, right? So I'll use intermediate signal here W1, W2, W3 as a wire. So already I discussed various data types in Verilog HDL, especially in hardware connection point of view. We have two data types, wire and reg. Already I discussed these two data types in Verilog HDL data types. If not, please look into that video and you'll get some insight, okay, about data types in Verilog. So now see, now this is the my output, like Verilog code for this full adder. So module full adder having inputs a b c as input and output sum and carry. So here just I list the ports and I declare those as input here, but we can do like this also. In this basis also you can mention those as a input a comma b comma c. Either you can do like this or you can do like this. Here just list of the ports and here declare the ports as input and outputs. Or while definition here itself you can mention those are input or output. So input a comma b comma c and output sum comma carry. So these are the intermediate signal W1, W2, W3. Those are declared as a wire. So already we know that the concept of wire, okay, in Verilog. Why we need this wire data types to connect different entities in a given model. We'll use a wire. Clear? Right. Now see, just we have two off adders and one OR gate. Now I instantiate this off adder in my given full adder. Now see, off adder. So what is this? This is a module name. This is the off adder. This is a module name. So using that module name off adder, and this is the instance name of adder 1. This is the HVN. This one is the instance name. Clear? So now a comma b. So now this a b. This a is okay connected to this a. Okay, this b is connected to this b. Sum comma like see here W1. What is the W1? Actual off adder produce a sum. Okay, as a third signal if you see sum. So W1 produce as a sum. Here W2 as a carry. So now see, if this off adder having a two inputs a comma b and that output is sum, that is here W1. So now W1 connected to the sum of this off adder. So now I instantiated another off adder. The instant name is off adder 2 right here. So what is the input for this off adder? One is the W1, output of this off adder. Now I'll connect this W1 as one input and another input is the C. So now see, this is the another input for this off adder. The C comma W1 the input for this off adder. And what is the output? So this is a direct output sum. Okay, and that carry is known as here W3. So now I'll use this W2 and W3, okay, as an input for this OR gate to produce the carry. So assign carry equal to W2 or W3. So here just I'll instantiate two off adders and one continuous assignment for this OR gate. I hope you understand. See, so now instantiation is different. Calling a function in like a C and Java is different. So instantiation means you're placing complete code here. Simply, so if you observe, this off adder contains two, this full adder contains two off adders. If you instantiate off adder in this full adder means, so in this full adder we have a two off adders and OR gates. Completely we are using that. So in hardware point of view, if you see the full adder, it contains two off adder inside. Okay, it's not like a calling a function, okay, executing that subroutine. It's not like that. Actually we are placing complete off adder in a full adder. Right? I hope you understand how to instantiate, okay, one module in another module. Now see, instantiation allows one module to include a copy of another module. Just we are copying of off adder in a full adder. Clear? And the instantiation statements create one or more named instances of a defined model. So here different instance of HA1, HA2, different instances, okay, for a given of order model. I hope you understand how to instantiate a one model in another model in Verilog. Now see, so how many ways we can instantiate? So port mapping in model instantiation can be done in two different ways. One is the port mapping by order. So same order we are following. So while defining the model, which order we are using in the ports list, same order we are using in the instantiation. I'll explain. Okay. Another is port mapping by name. We using directly name. No need to follow the order. By using the name of that ports, we can connect. Now see, so same example I'll take. So it is a simple full adder. Okay, 1-bit full adder using off adders, having a 2 off adders and OR gate. Now see, so this is the off adder Verilog program, right? Now I hope you understand. Now see, how do I instantiate these 2 off adders? Here, two ways we can connect: port by mapping, port by mapping by order and by name. So this example is port mapping by order list. Now same here, module name full adder, inputs a comma b comma c, and output sum comma carry. So just you declare those a b c as a input, sum carry as a output. So we need some intermediate signal, okay, internal signals, where we declare wire w1, w2, w3. Now off order instance name, we are instantiating off order by using module name, and we are providing some instance name off order 1. So now a, so now this a, this abc, this a is connected to a of this off order first, and this b is connected to the off order of off order 1 input b, and this w1 means, so this sum is connected to the w1. Okay, this w1 is like nothing but sum of this off order. Okay, the sum here, this sum is connected to the w1, carry is connected to the w2, like that. So I'll use same order. Now a is input, b is the input, same way a b is the input, and sum is output. Now w1 is output, so sum is connected to the w1 and carry is connected to the w2. Same way, if we instantiate another off order, instant name is off order 2. Now what is the input for this off order? Now c, one input is the c. Now we are connecting, c is the input, like is c connected to a of this off order, and w1 is connected to a of this off order 2. Okay, one input of this off order 2. Clear? And the sum, the output of this off order is the sum, directly connect to the output port sum. Now see this w3. What is the w3? Here w3 is connected to the carry of this off order 2. Now w3 nothing but carry of off order 2. Same way is a OR gate. Okay, 2 inputs w to w, we are getting carry. So now what we do here, port mapping by order list. While instantiating, I'll use the same order, like wherever, like see in this model definition, I'll use input a comma b, sum comma carry. Same way a comma b, w1 comma w2. So a is the input a, b is the input of b input of this off order. Okay, w1 is the output of this sum. Okay, as the output. Okay, w2 nothing but carry is the output in w2, like that. So we are following the same order. Clear? So another way of instantiating is port mapping by names. Now see in this example, so module full adder a b c as input, sum carry. So I declare a b c as input, sum carry as output, intermediate signal declaration wire w1, w2, w3. Now I'm instantiating one off adder, so instant name is off adder 1. So in earlier case I'll follow the order. Now here no need to follow order. So what is that here? Now see this a, what is this a? This a is belongs to this a. Now this a is connected to the actual a of this full adder. Now this b is connected to the b of this full adder. Now see this sum nothing but this w1 of this full adder. Okay, this w1 is intermediate signal. This w1 is connected to the sum. Clear? This w2 connected to the carry. No need to follow in the same order. You can write sum later, carry first. Okay, you can write the sum after this carry, or carry maybe before this input a comma b. You can write, you can follow in any order, because we are mapping the ports by using a name. Okay, not in terms of order. Okay, now see in the off order 2. Okay, instant name off order 2. Now a, this a is the input of this off order, is connected to the c of this full adder. Okay, now the c connected to the off order 2 inputs, and w1 is connected to the input of this off order 2. Now see w1 is connected to the b of this off order 2. Same way, sum is connected to sum and W3 connected to like carry. Like that we will get. I hope you understand how to instantiate, okay, modules in another module, okay, by using order, okay, and by using name. So here is port mapping by order and port mapping by name. So industry will use, we prefer this type of port mapping by name, because we have bunch of signal. We no need to follow the same order. Just if you remember the names, then you can write it. Clear? I hope you understood, okay, what is a module in Verilog, how to instantiate a module in another module. Clear? So in this video, I explained, okay, the concept of module in Verilog. It is a one of the most fundamental concept in Verilog. Okay, if you want to write anything in Verilog as a model only, and you should know how to instantiate one model in another model also. And also we can see parameterized model also. In coming lectures I'll explain, okay, what is mean parameterized models and everything. Okay, thank you very much.